Alright, boys and girls, welcome back to the drive-through for another edition of Mr. Euland Acts Like a Physics Teacher and Fails. Hope you guys are enjoying your little journey here. Here's some help on number 25. I think I'm ready to go on this to help you. Okay. Here we got our horizon. There we have the angle of our plane. It's 30 degrees. And we have a 900-pound block. Oh boy. A 900-pound block. And that force is being directed completely down in the negative J direction because it's a gravitational force. So that 300 should be a 30 degrees. So let's fix that first, of course. Okay, so let's finish out what else we know. We know this is a right angle. We know that this is 60 degrees. They want the unit vector along the ramp in the upward direction. Okay? Well, it's important to realize that this is where the negative 900 is. 900 pounds down. Okay? So what we need to do to find the unit vector, but they want it in the upward direction, so we'll get to that. We need to figure out what this is. Because remember, we do vectors like that. And what it truly is asking us to do, it's in the upward direction, is find that vector, okay, but make it 1 unit long. Well, let's just find the vector first. Here's our situation. We have this one, and we have this one, and they're asking us for this one. All right, well, we know that this is 900, and this is 30, and they're asking for it in the upward direction. So if this is 60, then remember from your 30, 60, 90 triangles, to get from the short leg to the hypotenuse, you multiply by 2. And to get from the short leg to the long leg, you multiply by radical 3. Okay? So the vector, the green vector, which we'll just call G as in the green vector, is definitely 900 radical 3 comma 900. Well, how do we find the unit vector in that direction? Well, we would need to just take that and divide it by the magnitude of the vector. That's how you make anything a unit vector. So the magnitude of G is going to be the square root of 900 radical 3 squared plus 900 squared, and that is 1800. Now, if you know a lot about vectors, that should make sense, because literally 1800 is the length of that vector. But if you feel more confident, then you can do the math and make sure that your assumptions are correct. So the unit vector would be 900 radical 3 comma 900 divided by the magnitude of U, or the magnitude of G, excuse me, which is 1800. And you get radical 3 over 2 comma 1/2. That's how they got that. Okay? Now, the projection of F onto U. Remember, U's on the bottom, so U's on the bottom of this equation. So the projection of F onto U is always one of my favorite videos to make. F dot U, Mr. Pletz, over the magnitude of U squared times U again, buddy. All right, so F dot U. That is going to be, well, our F is negative 900j. So that's 0 comma negative 900. Remember, to do the dot product, you multiply these. So that's 0. Then you multiply these. You add them. So that's going to be negative 81 with 4 zeros all over the magnitude of u. Okay, that's nice. It's a unit vector. So how big is that? It's 1 squared. Oh, no. F dot u. F is, sorry. Hold on. Back this up. Okay, not that. 900, negative 900 times a half. Excuse me. So that's negative 450. I was like, this is way too big. And then all of that times the unit vector, which is, we decided, radical 3 over 2, comma 1/2. All right, so what do you get? You get negative 450 times radical 3 over 2, comma 1/2. And what do you get? Bam! That. You get negative 225 radical 3, comma negative 225. Okay? Now, what's the magnitude of the projection of F onto U? Well, that's just going to be the square root of 225 radical 3 squared plus negative 200. Doesn't matter if we do the negative squared. But hold on, I didn't need to do that anyway, because this is a unit vector and ends up that the magnitude is 450, which came from that times 1. So what does that mean? Okay, this is like important. This thing weighs 900 pounds, but that weight is being distributed, okay? 450 of the pounds, let's see, are going that way, which means the remainder of the weight is being transferred into the wood on the ramp. So that gravitational weight, part of it is wanting to slide down and the other part is pushing against the ramp, and that helps us figure out lots of stuff. I hope that helps, Sam. So what does that tell us? It tells us the force required to stop the boat from rolling down the ramp. If you made it this far in the video, I'm proud of you. You might have to watch it again. Hard stuff, but be gritty. Love you guys. Boom!